Hello there again, it's John Ball. Welcome to another exciting episode of CIS 1500 Java 1. This is Lecture 6. We're finishing off Chapter 3. We left off technically right before 3.9, so we're going to be picking up right there. Oops. We're going to pick up at the switch statement, which is another selection control structure or decision structure, a multiple alternative decision structure. In this case, we're starting where we left off on slide 40. We left off on the conditional operator, and we're starting on slide 41 for the switch statement. The if-else statement that we saw before allows you to make true-false branches. So in other words, you go one way or the other. The switch statement allows you to use an ordinal value to determine how a program will branch. The switch statement can evaluate an integer type or character type variable and make decisions based on that value. And as of Java 7, you can actually use a string. So if you're using any version prior to that, you can only use integer and character types. And you can use char, byte, short, int, and then if you have Java 7 or later, you can use a string value. So the general structure looks like this. You have the switch statement, and then in parentheses, just like a method, you have the test value or test expression right there, and then you have a series of cases. So basically what you're doing is when the switch statement executes, it compares the value of this test expression right here. In this case, they're calling it switch expression. It's testing it with the values that follow each of the case statements from the top to the bottom. So notice here you have case and then whatever expression you're comparing this switch expression to, then a colon, then you put the statements that you want to execute here, and then you should put a break statement here. And then at the very end you have default, which is kind of like a trailing else if you had a bunch of if-elses. The default is what will execute if it can't find a suitable value up here, a suitable match between the switch expression and the case expressions up here. So the switch statement will evaluate the switch expression, which can be a byte, short, int, long, or char. If you are using Java 7, or eventually later, the switch expression can also be a string. Okay, so prior to that, you could not switch on a string value here, which is not the case with, obviously, if statements. You can use any of the types as long as you do the comparisons correctly. If there's an associated case statement that matches that value, the program execution will be transferred to that case statement. So each case statement has a corresponding case expression that must be unique. In other words, this one right here can't match another case expression inside of the switch statement. If the switch expression matches the case expression, the Java statements between the colon, so between this colon right here, the two dots, anything in here between that colon and the break statement will be executed. The break statement ends the case statement. The break statement is optional, but if a case does not contain a break, then the program execution continues into the next case. The default section is optional and will be executed if no case expression matches the switch expression value. So we'll look at a couple examples here. The first one, we'll create a new project here, Java project, and we'll call it Lecture 6 Examples. Okay, got an empty source folder here. We're going to add a source here. Just going to add a class. and we'll call this one pet food. Java. Oops, just pet food. It'll add the .java. We could create a package to include this, and we'll call this maybe com dot whatever your name is, and then we'll put like 6. Okay. So you should get in the habit of not using the default package. I think last week and a couple other times we've not used a special package, but remember that you for a package you just use what's called reverse URL or reverse DNS notation. You start with a com or .org.edu or edu.com.org. whatever, and then you put a some middle level qualifier, and then at the very end you have the name of the package itself that lives inside of this. So this basically sets, in some logical way, it sets a series of folders. At least in Eclipse it does. So you have com.profjpbaugh.lex6. Now notice that even though I personally do own the domain name profjpbaugh.com, it is not necessary in order to make a package like this. It's not considered necessary that you own that domain name. Okay. Some people choose to do it because the end user may not ever see anything that has to do with this. Okay, so once you do that, we click Finish at the pet food class. We need to put a main, public static void name, string, array, args. All right. Now what we're going to do, we do need to use a scanner in order to get input. So I'm going to import. Now, obviously, Eclipse will do this for you. It'll warn you, and then you can tell it what you need. But we're going to put it at the top to just get used to what the packages are that we have to import. Java.util.scanner comes out of the utility package. We have scanner. We need that in order to obtain user input. So we're going to create a string input here that'll hold the user's input. Char food grade. This will be the grade of pet food. Okay. And we're going to create a scanner now. So we create a scanner. We're going to say scanner keyboard equals new scanner, and then the parameter that we pass into the scanner indicates where the input comes from. In this case, it'll be system.in. Standard input. In this case, it'll be the keyboard. Now we're going to prompt the user for the grade of pet food. So I'm going to put system. Let's actually put a little extra space here. Okay, so system.out.println. We're going to say our pet food is available in. And we're going to say 3 grades. All right. So we're going to put system.out.print. In this case, notice it's a print, not a print line. We'll say which do you want pricing for? All right. So then we put an extra space there. We could also clean it up if we want to. We could put, say, a plus symbol there. And we'll just put that on the second line just to reduce the number of spaces it takes up on one line. Input is going to equal keyboard.nextLine. And then food grade is going to equal input.char@0. That will give the first character. Now, we're assuming the user is going to enter a single character anyway, so this string should have single character length. But in order to have it converted to a character data type, we have to call char@ on the input, which is the string. Say char@0. That gives the at the position 0 within the string. So each character in the string is has its own index. We'll talk more about arrays as we move along, but it kind of acts as an array. It's a collection of elements. The first character in the string, say if the string was John, the first character would be at location 0. and that would be a J. Then location 1 would be a lowercase o, location 2 is lowercase h, location 3 is a lowercase n. So in this case, even though they're hopefully only putting in one character, we need to convert it to a character data type. So sorry, that should have been on the next line. Food grade equals input, which is the string, dot char at. So that converts it to a character by looking at the first character in the string, which hopefully is only one character long anyway. So we're switching on the food grade. If they type in a lowercase a, we want to be able to cascade through here. And I'm going to tab that in there. So this is why the break statement in this case is not there, because we want it to cascade on through. If they put a lowercase a or an uppercase a, we want it to go down to this and say 30 cents per pound, and then put a break statement. Right. The next case is lowercase b or uppercase b. We'll put system.out. Oh, this one needs a closing single quote. We've got system.out.print line. We'll say if it's grade B, it's 20 cents per pound. Alright, and we're going to put a break statement there. Case C. Case C. System.out.print. 10 cents per pound. Right. And then finally, default. So we have the default here. We're going to say system.out.print. Print line will say invalid choice. So if they put anything else, it'll be an invalid choice. All right. So let's see what happens here. If we run the program, you'll notice at the bottom here, it will say pet food's available in 3 grades, A, B, and C. Which do you want? We're going to put, say, A. And then it'll execute the program and execute the switch statement. It'll pick the correct, the corresponding food grade for what character we entered, which was an A this time. So it tells us it's 30, centers per pound. That's just cute. Okay, that should be cents. Sorry. I did it on all 3, which was kind of funny. Okay, 10 cents per pound. I don't know where I got why I was thinking centers. Okay, so you've got 30 cents per pound in this case. If I run it again, I'm going to put lowercase b just to test. So lowercase b says 20 cents per pound, and that's exactly what we expect up in the switch statement here. You'll notice that we have, anytime they put a lowercase, it actually just bumps right on down. It does not break out of the switch statement. It goes straight down to the next one, and then cascades into this one right here, whatever the code is between the colon and the break statement. So it does what we call cascading or sliding down into the code segment here. Same thing with B and same thing with C. Now default means if it was an invalid choice. So let's put an invalid choice. Let's say I want to buy extremely bad dog food, grade Z, and it'll tell us that's an invalid choice. Probably kill your dog and be extremely cheap. Maybe they'll pay you to get rid of it. So that's one thing we can do. Notice in this case, what we're switching upon is a character. Okay, you can also switch upon integers, and if you're using Java 7, at least you can switch upon strings, which is exactly what we're going to do next. Okay, so I'm going to right-click the package here. Since we have a package here, I'm going to right-click that and then go and create a new class. This one's going to be called seasons.java. Or season, sorry, I always have a habit put .java. It's going to be called seasons. You click finish. Alright, and then we're going to put our main, public static void main, string args, And as I'll show you what happens if you try to create a scanner and you don't import the java.util.scanner, it's actually going to complain about it. So we'll look at that in just a second here. I'll leave it alone for now, and then we'll say string input. We're getting a string that we need to use for the input that's going to come in. And then we're going to say scanner keyboard equals new scanner system.in. Okay? Now you'll notice what happens here. If I did not import the Java util scanner class, it doesn't know where it comes from, because it's not built into the Java language. It is built into the Java API. If I hover over scanner, now this is not necessarily going to happen in all IDEs or all compiler environments, but in Eclipse they give you quick fixes, and you have to pick which one, or you can try your own. But in this case it says 7 quick fixes available, and you'll notice the top one says import scanner java.util. It also says you can create a class named scanner. Maybe you forgot to create a class or an interface, or change to signer. Maybe there's java.security, it recognizes something else. But in this case, it's definitely that we forgot to import java.util scanner. So now you see import java.util scanner at the top, and that's what we could have done at the very beginning to avoid this mess. But we're good. Eclipse is very helpful at that, but don't let Eclipse do your homework for you. You need to try to memorize what belongs in what libraries. It could end up on a test or something. Okay, so get a day from the user, system.out.print, enter the name of a season, and what this one's going to do, this program is going to translate it from English into Spanish. So you've got input equals keyboard dot next line, so that grabs the string, and now we're going to translate. Okay, so we're going to switch on the input. I usually like putting comments at the end to indicate where the input ends. We'll say case spring. In this case, we're requiring that they type it in all lowercase. Case spring. I do not think I like actually indenting it a little more. So in spring, in Spanish is la primavera. La primavera. Right? And then you have case summer. Case summer system.out.println. And summer in Spanish is el verano. And then case, now this is a special case. You might have autumn, someone might type autumn, but they also might type fall. Because in English we call those two different things. Some people prefer calling it autumn, some people prefer calling it fall. So we're allowing them to put either of those. And autumn and fall in Spanish is el otoño. Alright. And then finally we have winter. System.out.print line. El invierno. El invierno. Okay. Alright. And we break there. And then default, we're going to print out, please enter one of the following, or one of these, we'll say one of these words. We'll keep it consistent with what they do in the book. And we're going to put a plus sign there, and we're going to say spring, summer, autumn, fall, or winter. Alright, so we're allowing them to enter one of these 5 possible phrases, but the default tells them that when they get it wrong. So let's run it and see what happens. I will run the program, and down at the bottom it says enter the name of a season. Let's put chicken just to see that it goes down to the default. Please enter one of these. That should be one of these words. We'll change that. See, this is why we do testing. Run it again, and when we run it again, we'll enter spring, and it tells us la primavera, and then we run it again. We'll test summer, el verano, run it again, and we have, let's type in autumn, el otoño, right, run it again. We could say fall, el otoño, same thing, and then we could do a thorough test and just finish it out with winter, el invierno. So it goes through the whole thing. It can match if we don't get a correct phrase to translate it. So the sky's the limit with a lot of this. I mean, you could, especially with Java 7, with Java 7, since we're able to switch on a string, that makes things a lot more interesting and a lot easier in a lot of ways. So switch statement can sometimes be natural for the way that things should work. So it sometimes makes sense to use a switch statement instead of a series of if statements. Now you notice that you could, even on this one with the strings, you could put, if input dot equals spring, else if equal input dot equals summer, else if input dot equals autumn, else if or you could put an or statement here because these should be the same thing. So I mean, we could do this with an if-else statement, and a lot of people prefer that, and that's fine. But this is just showing you. This is just showing you that the options that you have as far as selection statements are concerned. Okay, so the next thing we're going to cover is from section 3.10. This is the system out printf method. In this case, you can use the system.out.printf method to perform formatted console output. The general format of this method is system.out, just like system.out.print or system.out.println for printing a string with a new line character attached at the end automatically. We have system.out.printf. Now, at the beginning, the first parameter, if you use two-parameter version of this, the first parameter is the format string. The format string is the string you want to print out along with any, it's got text and special formatting specifiers, or it could contain both. The argument list is a list of 0 or more additional arguments, which will be formatted according to the format specifiers listed in the format string. Now this will make more sense once we use it. Okay, so, but we'll look at this for a second. The format string, so again, like I said, this is the string that contains the text and or special formatting specifiers. And you've got the argument list, which is optional. It is only optional if you don't use any of the special formatting specifiers. So you could do a simple one where you just say system.out.printf hello world and you not have any formatting specifiers. All this is going to do is it's going to behave like print, regular print method. This won't have anything to format. But in some cases you want to specify certain things. And what we want to do is we're going to do a specific example to show how this works in usage. Now note that there are different parameters when you use format specifiers, different types, different syntax. You've got the we'll see if it shows us here. If not, we'll go over it more thoroughly. But you see the %d here. It says I worked %d. This is a placeholder essentially. In this case, it indicates that a decimal integer will be printed. Okay, it is an integer. All right. So you've got %d, which is a decimal integer. I worked, and then there's a placeholder, hours. So that will go into this string. Notice that hours is after the comma, after the double quote. So this is the format string right here, the one that says I worked %d hours with the new line character built in here. So at the end of that, you have a comma, and then this is the one argument. The one argument in the argument list, and this particular argument, since this is the only format specifier, or the first format specifier, this matches up with the first argument after the format string, of course. So hours and this match up. So wherever it sees hours, which in this case is 40, it's going to replace that %d with the 40. So that's exactly what we would see if we run this. Now in another case, let's say int dog equals 2, cats equals 4. I could say printf. In this case, we could say we have %d dogs and %d cats. Now, how does it know which one's which? Well, it goes by order. You have the format string right here. The first %d, the first format specifier, will match up with dogs. The second one will match up with cats, whatever the variable cats is. That's why it says we have 2 dogs and 4 cats. So this %d is replaced by the value inside of the first parameter after the format specifier. In this case, it's dogs, which contains a 2. And then we have cats, which is the second one. That replaces the second format specifier. And the variable cats contains a 4 by the time we use printf here. All right. So you can also use the printf method with variables that have floating points. So it's not just limited to integers. For example, this will work with floats or doubles. You can say double gross pay equals 847.12, and then you can print out system.out.printf, your pay is %f in this case, because it's a floating point type. And then after the format string, you have comma, and then the argument. Gross pay, which contains 874.12, will be replaced in the %f. Notice that it prints out with 6 decimal place precision, even though we don't need it. So we can control that also. We'll talk about that in a second. Okay. You can specify that we want, for example, to put 2 decimal places right here. Now the syntax may look a little bit funny here, but this right here is exactly what the format specifier looks like. The % symbol begins a format specifier. So any format specifier that you use, whether it's % for F, D, or S for string, whatever you use, you have to begin it with a %, and it has to end with the what's called the conversion character. Okay, for example, the F right here, notice it begins with % sign and ends with the conversion symbol. In between, you can have any number of things, and I'll refer you to page 165. It has a list of different things on format specifier syntax. You can have flags. They will appear immediately after the % symbol if there are any flags. Flags will cause the value to be formatted in a variety of ways. Then you can have width. After any flags, you can optionally specify the minimum field width for the value. And then you have dot precision. Now this is where it comes in for what we're doing here. Since the precision that we had was too great for the last situation we had, how it started printing out 847 or 874.120000. It's too many zeros at the end, and we don't need that level of precision, even if it weren't zeros. We want it to be precision of 2. So these, look at these as delimiters. These are kind of like the curly braces of the format specifier world. You have the % on one side and then the conversion character on the right. In between, we have 0.2. Now that corresponds to what they call point precision, dot precision. You have to put a dot, and then you indicate how many decimal places. So it's the number of decimal places that the number should be rounded to. So what we get this time, since we've specified we want 2 decimal places, you get your pay is, and then 874.12. Okay, if we made it 0.3, it would say 120 in this case. All right. So now the comma, if you want to put a comma to format your values, then you can put the comma right after the percent sign. If you notice that the comma is right after the percent sign in here, that's one of the optional flags that can cause your value to be formatted specifically. So if you want it to be formatted with commas, that's one of the flags. So this is a flag, comma's a flag, and then the .2 is what we just used before. So remember, the dot is a special symbol to indicate that it starts at precision. So .2 means we've got a precision of 2. The comma that comes before it just says we want this to be formatted with commas. So in the output, it says now your pay is 5,874.13. So now another example we can use with strings as well. So we've done percent %d for decimal integers. These are integers that are in the decimal system, so base 10 system. That's what the D is for, but they are still integers. And then we've got percent %f, which is for floating point types, such as double and such as float, which are the two floating point types. Now we can also use percent %s if it's a string. Okay, so we can say string name equals, then put the string in here, and then say system.out.printf your name is, and then put the format specifier here, and then after the format string you have the argument, which is name. Name contains Ringo. It replaces the value of percent %s. So then when it prints out, it'll say your name is Ringo. You can also specify a field width. Now, one of the other options they gave you, after you specify the flag and before you specify any precision, you specify a width. So if you put right after the percent symbol and any flags that you have, if you put anything before a period, if you put a period here, it would interpret it as precision. But since there's no period here, right after the percent sign, the only thing we come in contact with is a number before the D. Again, remember that the percent on one side, on the left side, and then the D on the right side are basically delimiters saying this is a format specifier for a decimal integer. So the first character is the percent sign, which all format specifiers have, and the ending symbol is the D, which is the conversion character, which says this is what this the argument that corresponds to this should be converted to. Well, what does the number in between mean? In this case, if you just put a number, remember there's not a dot in front of it. That's how you distinguish it between that and the width and precision. If you don't have a dot in front of it, it says that's the field width. So that means that the integer should be displayed in a field that is 6 spaces wide. That's why you get the value is and then all these spaces here, and then a 9. So you've got 9 and then 5 spaces in front of it. So in total it's 6 spaces. All right. Now notice you can do both. Okay. Notice that you can put percent. You've got percent on one side, F on the other. So that says this is a floating point type. You've got 6.2. So what does that mean? Well, don't think of it as a complete number here. The number after the period specifies the precision. That tells us that the 0.77, it'll round this value up. So it'll round it up or down depending on what the scenario is. The number before says it has to be, before a period says it has to be within 6 spaces. So this whole thing will be within 6 spaces. You got 1, 2, 3, 4 for the number, and then 2 extra spaces in front of it. So we're going to do an actual example here, just so you can see what's going on. Oops, don't want another Java project. I want a new class. In this case, we're going to do the example on page 169. It's the currency format. It's pretty simple and pretty straightforward. So we'll call currency format not .java. Okay. Do that, and then we'll say public void main string args. Okay. And here we'll say double monthly pay is equal to 5,000.0, and double annual pay is monthly pay times 12. System.out.printf. We'll say your annual pay is, we have a $sign, and then you have your format specifier. You want to put percent sign, a comma, that's a flag that indicates we want to format it with commas, then a 0.2, so that indicates with 0.2 decimal place precision, then the F to end that. But the F is the conversion character, which indicates that it's a floating point type, which makes sense because we have decimal point indication. Annual pay, and now we're going to print it out. So at the very bottom, you'll notice in the console it says your annual pay is $60,000. Okay, that makes sense. And it's pretty much exactly what we expected, I would think, right? We've also got the decimal format class. So the decimal format class is useful for a multitude of reasons, but you might wonder if you read up on it or messed around with it any, you might wonder why do we actually need it, because it seems like printf takes care of all that. Well, that's true that printf does do that for the console, but in a lot of cases your data might not be sent to a console. It could, for example, be set to display the formatted output in a graphical user interface. We can't use printf in that case, so we're going to use this class called the decimal format class. So when printing out double and float values, the full fractional value will be printed. Decimal format class can be used to format these values. In order to use the decimal format class, this import statement has to be put at the top. So we'll do an example here. We'll do format 1, which starts on page 175. We'll create a new class. We'll call it format 1, just like they do in the book. And again, keep in the habit of doing public static void main string args. Right. So this one we're going to use the J option pane, and we're also going to use the decimal formatter. So import Java extended javax.swing.j option pane, and then we're going to import the java.text.decimal format. Right. So the first thing we're going to do is we're going to create a few doubles here that mess with. So double number 1 equals 0.1 66666666666667. That's a lot of sixes. Okay. Double number 2 equals, I guess it's, yeah, they called it number. We'll call it number. Number 1, number 2. Doesn't really matter. Number 2 equal to 1 point, same level of precision here. Okay. Then double number 3. In this case, it's 16 point. Bunch of sixes. 187. And double number 4 is 166 point. Bunch of sixes. I'm just lining it up with the semicolon is how I'm actually doing this. I only counted the first one. I know these two are the same. This one's one more, so I need to extend that one more. So the 7 and the semicolon line up. And then the next one, oops, that should be 4, by the way. the next one lines up with that semicolon. So it's nothing magic. I'm just trying to use visual cues to help me out here. It's a lot of numbers that are the same. So decimal formatter equals new decimal format. Okay, and then we're going to use this format, and I'll explain what this means. Apparently they don't tell you in here. Oh, well, that's exciting. Okay, well, the first thing with the decimal formatter, you see a number symbol. If the number contains a digit in the position of a number character, for example, here, in the pattern, the digit will be displayed. Otherwise, no digit will be displayed. If the number contains a 0 in the particular position, then it will, if it does contain a digit there, then it's going to display the number itself, but otherwise it will display a 0. So if that makes sense, the number sign just means if there's no digit or no number in that particular digit, in that particular position, then it's going to just not print anything. But if there is, it will put it'll put nothing. And for the 0, if there isn't, it will put, or if there is, it'll put the digit that's specified in that position. If there isn't, it will put a 0. So if there is, puts the digit. If there isn't, puts a 0. So these behave similarly, except one doesn't put anything, the other puts a 0. So we have decimal format. Sorry. Decimal formatter. And then we're going to display the formatted variable contents. Okay, so J option pane. J option pane dot show message dialog. The first argument is going to be null. We haven't really dealt with option pane thoroughly. Okay, and now since should be number 1. We got number 1 here. Yeah, that should have an extra parenthesis. There we go. So in this case, I'm going to use kind of a shortcut here, because there are 4 of them, and the only thing that varies in any of these is the number here. So we're going to put number 1, number 2, number 3, and number 4. So copy and paste, Control C for copying a set of highlighted text, and Control V, not P, but V. Control V will paste. Okay. You can also go to Edit and do copy and paste as well. Okay, so excuse me. Let's look at what this does now. If we run it. So the first J option pane that pops up says 0.17. That's because you'll notice that it does say 0 and then point, and then whatever numbers are available afterwards. Then you have 1.67. Okay, so far so good. 16.67 and 166.67. So the decimal places, in this case 2 decimal places, everything seems to be working just fine. Now, you could modify this just slightly and see what the difference is. So this is actually what they call format2.java. They changed the formatter here to 00.00. So you get 00.17. So it forces it to print out zeros even when there's no value at that place. Then 01.67. Then it's just 16.67, and the reason is since there is a value at that location, we don't need to print out a 0 there. And then 166.67. That's exactly what we expect. Okay, so you could also format it with some special symbols. So I might put a number, comma, number 0 dot 00. So if it's a decimal place, or a decimal point number, it's just maybe 0.17 or what have you. It's going to still put the zeros. but it's going to truncate these values. But if these values do exist, it's going to start putting a comma there. If we get this value right here, it'll put a comma there, and it'll format with commas. So hit OK here. Oh, we probably need different numbers, don't we? We're going to need another number here. I'm going to put double number 5. I'm going to make this 1666 all the way over here. Okay, and then there we go. So now number 5, we're going to copy and paste the code down here and change that to a 5, and we should be able to see our handiwork here. Okay, 0.7, or 0.17, 1.67, 16.67, 166.67, and then you get the formatted thousands, 1000, comma, 666.67, and then we're good. So that's pretty useful. You can also use percentages. If you put a percent at the end, it would format it with a percent value. You have a bunch of different options as far as that's concerned. I encourage you to practice and get used to some of those. Another set of things that I want to briefly go over is what they call the section 3.12. They are telling you different errors to avoid. So the errors that they tell you to avoid, the first one is using the equal sign instead of the double equals to compare primitive values. So I'm on page 181 if you wish to follow along with your book. Using equal sign instead of equals to compare primitive values. Remember that the equals sign is the assignment operator, and equals tests for equality. Okay, so if you have an if statement, for example, and you want to say is a equal to 5, then you have to use the double equal sign. If you are trying to assign a value to the variable a or variable b or what have you, you say a equals 5 or a equals 10 or what have you. You also cannot use the double equals to compare string objects if you're trying to compare their values. Now, if you try to compare their references, like where they exist in memory, then use double equals, but that's a rare occurrence. It's not nearly as common as comparing the actual strings. To compare the actual strings, you say the name of the string dot equals, and then you pass it the name of the other string. So forgetting to enclose an if statement's Boolean expression in parentheses, Java requires that the Boolean expression being tested by an if statement be enclosed in a set of parentheses. You'll get an error, if compiler error in this case, if you omit the parentheses or use any other grouping characters. Writing a semicolon at the end of an if clause. When you write a semicolon at the end of an if clause, Java assumes that the conditionally executed statement is a null or empty statement. Now that one's harder to catch because it will not flag a compiler error. If you put if and then some condition and then you put a semicolon at the end of it, you're not supposed to do that because it is valid syntax, but it isn't good syntax. That's probably not what you expected. Forgetting to enclose multiple conditionally executed statements in braces. My rule when you do if statements, if and if else, is that you always use curly braces, even if it's one line. Always use curly braces and you won't have to worry about it. But if you put one statement right under an if statement header, and then later you come back and you put another, if you do not have curly braces around them, only the first one is conditionally executed. The other one will always be executed as if it was sequential. It doesn't matter the amount of indentation you use. That does not affect anything in Java. So omitting the trailing else in an if statement, it's not a syntax error, but it can lead to logical errors. So if you put if statement, and then you have another condition else if, another condition else if you don't put an else at the very bottom, you could have like an erroneous value, but you should always check for it even if you don't expect it to ever happen. You should always put a trailing else. It's almost always safer to do it that way. Not writing complete Boolean expressions on both sides of a logical AND or logical OR. If you recall, the logical AND are like the two AND symbols where you hit Shift 7 on the keyboard. That will logically put together two Boolean expressions. You have to have two Boolean expressions, Boolean expression on either side. Same thing with OR, which are the double vertical bar. You hold down Shift and hit the key right above the Enter key, which is a what we call the vertical pipe. It's the same key that the backslash is on. Those have to have Boolean expressions on either side. If you try to perform case-insensitive string comparisons with the string classes equals and compare two methods, you will probably end up very confused. If you want to perform case-insensitive string comparisons, you need to use the string cases equals, ignore case, and compare to ignore case methods. So the ignore case methods will ensure that you're comparing the words and not being concerned for the case. Using a switch expression that's not an int, short, byte, or char, the switch statement can only evaluate expressions that are int, short, byte, or char data types. If you're in Java 7 and greater, you can use a string, but if you try to use like a double type or something like that, you're going to have problems. So the next thing, which is on page 182, using a case expression that's not a literal or a final variable. Because the compiler must determine the value of a case expression at compile time, case expressions must be either literal values. Literal values would be the situation where we actually just wrote them here. We say, we put double quotes around them. That's a string literal. And since that's safe for compile time, it's okay. It knows it's not going to be changed. That's okay. The other way we could do it is if we made a bunch of constants. Remember when we used the final keyword? We could do that as well. Forgetting to write a colon at the end of a case statement. If you don't put the colon here, you're going to have a problem. The colon must appear after the case expression in each case statement. So we have case, keyword, and then the colon acts basically as a delimiter between the actual test value that you're testing for that particular case, and you have a colon and a case on either side, and then the value in between. You should also put a break statement as well. Forgetting to write a default section of switch statement is also not a syntax error. But just like the else situation, if you don't put a trailing else on a set of if-else statements, then you could have a particular coverage of the possible values that is not actually covered. So if it goes in and you have if, and then if else, if else, if else, perhaps there's a value you didn't consider, or you don't think that it's going to ever get to, and it gets to it, and then it'll just skip over your entire code, and maybe that's not the way you want to handle it. Maybe you want to print an error out to the console or to a file or what have you. If you reverse the question mark and the colon and the conditional operator, we went over the conditional operator, it's the only ternary operator in Java. Also, when formatting a number with system.out.printf, writing the flags filled with and precision in an incorrect order. Remember that the whole, in a printf, the whole format string goes first. It's the first parameter. So, the format string comes first. So you have to make sure that the format string comes first with the format specifiers inside, if any, then, comma, and then the list of any arguments to the format specifiers. When writing a format specifier for system.out.printf, using the wrong type indicator, a lot of people mess up with this. Make sure %f or %whatever f, the delimiters on either side are % and f. What does that mean? It's a floating point. If you have %d, that is an integer type. Okay. Now remember, the floating point can be either float or double. The integer type %d, that just means it's an integer, decimal integer, and then %s is for strings. Finally, forgetting to pass a formatting string to a decimal format's object constructor. The formatting string specifies how the object should format any numbers that are passed in to the format method. So you need to have that. All right. So I do recommend going over some of the examples in the book. If you have any questions, please feel free. If you have any questions on this particular chapter or any remaining questions for your assignments that are due coming up, please feel free to contact me at jpbaugh@oaklandcc.edu. You can also feel free to go to the discussion board, and I'm going to try to check that out in just a little bit and answer some questions as well. So if you have any questions like that, just please feel free to contact me or and have discussion with other students as well. As long as you're not cheating and helping each other too much. I think you probably can tell the difference between that. I'll step in if I see something too extreme. But just don't post all of your code or email someone your entire code base, and you should be okay. So, all right, if you have any questions, again, contact and stay in touch with everyone on the in touch with everyone on the discussion boards. I did create a discussion board just for the programming assignment, so if you feel like you need to talk about it, then you can feel free to do that. I'll create another one for the programming assignment too when we assign that next week, I think. So we could look at the syllabus really quick, just to make sure we're on task and we know what's going on. We'll review the syllabus. Okay, this is the week of the 10th. So the programming project number 1 is due on Valentine's Day, so February the 14th, 2014 at 11:59 p.m. Next week, we will go over loops and files. Programming project number 2 will be assigned, and we will study for the midterm. The week after that, you have a midterm, or a midwinter break. Then when you come back from the break, you will have the midterm. I will be asking everyone what days and times are best for them, and we will try to get stuff in a particular range. And if you're completely an outlier, we'll work out something for you, but I'm trying to hit or get as many students at once that I can. So, all right. If you have any questions, please feel free to contact me, and hope you have a good week, and keep studying. Bye.